So let's talk about the probability concepts. This is a topic you also have learned in your earlier grades. Well, the purpose in this grade is essentially to talk about what is the difference between experimental versus theoretical approach, and also to go over these learning objectives that we want to cover all of these basic definitions, the fundamental concepts in probability. All right. So let's first talk about the difference between experimental versus a theoretical approach. Okay. The basic concept of calculating the probability of any event E is still the same in both cases. It is the number of favorable outcomes to the total number of outcomes, right? So with that respect, we always define that probability of any event E is a number that is bigger than 0 and less than 1, right? Well, the difference really comes is when you are really calculating the total number of outcomes, the entire space of outcomes in a very theoretical way, then you say it is a theoretical approach. But on the other hand, if you actually run an experiment, a process or any activity to really determine what is your number of favorable outcomes to the total number of outcomes, that is what is called an experimental approach. Okay. Our focus in this chapter is more about the experimental approach. So let's take a look at some examples to go through all of this. My very first example is this, in which a coin is tossed 50 times. If the number of heads occurred 35 and the number of tails occurred 15 times, find the empirical probability of the occurrence of a head. Okay. So with reference to this learning objective, how do you define your experiment? I would say it is the tossing of a coin 50 times. That is precisely my experiment. Now, what is your desired event? The desired event is something that you wish to calculate the probability of that event, which is the occurrence of a head in this case, right? I will simply count how many times did I toss the coin, which is 50, which is exactly the total number of all outcomes to the total number of desired outcomes, and that happens to be 35, right? So the probability of head in this case is simply a ratio of these two numbers and 35 over 50, which is 7 over 10, right? Or you could say that based on this, I will calculate that the probability of a tail is 15 over 50. So this result actually gives rise to a very interesting definition, and that is about the complementary events. The way we define complementary events is, let's say there is an event E and then there is a complementary event to that known as P of E bar. If the sum of these two events is such that it is equal to 1, then E bar is known as the complementary to E, or E is the complementary to E bar. That is the relation between these two events, okay? And such events are called complementary events. So with reference to this result, I can very easily say that if I simply sum up these two events, the probability of head and probability of a tail, then I will get the net result equal to 1, right? Hence, I can say that finding a head or finding a tail in any experiment like this is a good example of a complementary event, okay? So now let's talk about what are sure events and what are impossible events. So think about this. If I say that I toss a coin 50 times, find me the probability of getting a head greater than 50. So what is that probability? You will say that probability of finding a head greater than 50 is equal to 0. Then that will be called impossible event because it's never going to happen, right? On the other hand, if I say that in this experiment, when I toss a coin, I'm going to get a head or a tail, one of these two outcomes, right? Then it is called the sure events because definitely you're going to get one of these two, right? So this gives you some idea about how to define your sure events versus impossible events. So with reference to that, let's take a look at one more example to understand some of these terms a little better, okay? Our next task is this one, in which 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes as shown in the table. So the outcomes are 3 heads or 2 heads or 1 head or no head, and these are the respective frequencies. Let's answer some of the questions. First of all, what is the experiment? Experiment is 3 coins that are tossed 200 times, right? What is your desired versus non-desired outcome? In this case, we want to compute the probability of 2 heads coming up. So I will say that this is my desired outcome. And all of the other, even though they are happening, but they are not my desired outcome. And then we are going to take a look at equally likely versus not equally likely. Okay. So let's calculate all of these probabilities. Okay. In this case, I will say probability of respective head is equal to 23 over 200. Why? Because out of this experiment that I ran 200 times, I got 3 heads 23 times. So this is the respective probability based on this definition. And likewise, I will say that for my desired outcome, which is getting 2 heads, this probability is 72 over 200. Correct? 72 out of 200 times I get 2 heads. Hence, this is my probability. Then I will say getting 1 head is 77 over 200. And finally, no head is 28 over 200. Okay. Now you see all these outcomes, they have very different probabilities because 23 over 200 is not the same as any of these events, right? The probability of happening all of these events is not equally likely, right? If we would have found that based on this experiment, if each one of those events were equal number of times happening, then we could have categorized them as equally likely. Hence, we will say that based on this specific experiment only, we will say that all of these events are not equally likely. All right. Next experiment could give you a completely different results. We are focusing our discussion only strictly based on this experiment. Okay. So you should always keep that in mind when you discuss about equally likely versus not equally likely. So now let's talk about the next definition, which is dependent versus independent events. Well, in this experiment, you see that there are 3 coins, coin 1, coin 2, and coin 3. Each one of those could result either a head or a tail, right? There are only 2 possible outcomes for each coin. But you see that whatever happens to coin 1, whether it results in a head or a tail, it has no bearing on the coin 2. There is no relation between these 2 events, right? If one results in a tail, second could very well result in a head. There is no connection between them, right? Likewise, there is no connection between the second and third. They are also independent of each other. So this is the point. They are independent events. If they were to influence each other, then we say that they are dependent events. So that is all about what we wanted to learn in this chapter, that we wanted to cover all of these basic fundamentals, that various definitions in the school of thought related to the experimental approach. Okay. So with that, let's pause here and proceed on to our quiz and exam modules.